Okay, both these groups are cyclic groups, finite cyclic groups. Both are generated by 1, right? Okay, 1, so we have, for instance, this group here, the additive group with 7 elements is this one, is 0, 1, 2, 3, 4, 5, and 6, right? And you can generate it by 1 because 1 square is 2, and 1 cube is 3. Remember, the power here, so 1 to the m means 1 plus 1 plus 1 m times, which means this is m, right? Because it's an additive group, okay? So 1 to the m is just m. So clearly the powers of 1 are generating 1, 2, 3, 4, 5, 6, and then the next one is 7, which is 0, okay? And that's the order of 1, right? And the same with 8, okay? Same with this group here. It says they're generated by the same generator 1. All right. We need to find all proper subgroups of these two groups here. And if we apply Lagrange's theorem, that means that if you have a proper subgroup, the order of the subgroup must be a divisor, a proper divisor of the order of the group, right? So if we focus on this one, right, this one here, the cardinal of this one, so the order of the group, okay, is 7, which is a prime number. So it's got no proper divisor, so it's only divisible by 7 and 1. So this group has no proper subgroups. Okay. Now we focus on this one, right? And this one has cardinal 8, right? So the order is 8. So the divisors are 2, proper divisors are 2 and 4, right? Of course, 1 and 8, 2, but these are the proper divisors. So the proper subgroups must be of order 2 and of order 4, right? We not only know that, we know that since this is a cyclic group, right, all subgroups are monogenic, which means that all subgroups have this form, 1 to the m, right? And that the cardinal of this group, the order of this group, is the least common multiple of m and the order of the group 8 divided by m. Okay? So we know this, right? So if m is equal to 3, 5, and 7, then the least common multiple divided by m is just 8, because the greatest common divisor of m and 8 is equal to 1. Remember that the least common multiple, another way of writing this, the least common multiple is as the product, well, 8 times m divided by the greatest common divisor. So m and 8. Or, so if you prefer, this can be written just like this. Okay? All right. So if these are co-primes with 8, which they are, then the greatest common divisor is 1, and therefore this is 8. So this group is also generated by 3, by 5, and by 7. These are 4 generators of the same group, right? Now let's see what happens with 2. Well, the order of this group, this subgroup, must be, well, you put 2 here, and then you have 2. This is the greatest common divisor, so this is 4. So the order is 4, and actually this is what happens. This is just 2. 2 plus 2 is 4. 4 plus 2 is 6, and 6 plus 2 is 8, which is 0 modulo 8. And then you have generated the whole subgroup, right? So this is a proper subgroup. Not only this one, right? If you take 6, for instance, same happened with 6, right? The greatest common divisor of 6 and 8 is 2 again. So we have exactly the same order. And if you take 6 here, you get the same thing. You have 6 here, 6 plus 6 is 12. 12 is 4, right, modulo 8. Now if you add 6 more to 4 is 10. 10 is 2, modulo 8. And if you add 6 more to 2, you get 8, which is 0, modulo m. So it's exactly the same group as this one. These two subgroups are identical, okay? And finally, we have all the numbers. You have 1, 2, 3, 5, 6, 7. So it's 4, the one that is missing. Of course, if you put 4 here, you have the greatest common divisor is 4, and then you get here 2. So we know that this subgroup has order 2. And actually, that is what it is, because if you take 4 and you use that as a generator, 4 plus 4 is 8, which is 0. So these are the two elements of this group, right? So here's the subgroup structure of this group here. So you have, of course, 0, right, which is it's an improper subgroup. Then you have the subgroup of two elements, 0 and 4. And you have the subgroup of 4 elements. Both these subgroups are the same, right? So it's 0, 2, 4, and 6. Okay, and finally you have the group, which is 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so these two are the two only proper subgroups of this group.